Hi, this is Miss McClellan here to go over practice 2.1.2 with you. This is some proofs we'll do to prove triangle congruence. And the first problem is prove triangle ABC is congruent to triangle PQR. Okay, I can see right away that I have three given congruent sides, so I already know I'm going to be using side, side, side. So I'm going to start with my conclusion. Side, 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 conclusion. That's my conclusion. And then let me name my triangles to write my congruent statement. Triangle ABC is congruent to triangle. Okay, now we have to be careful to match up our vertices. A corresponds to P. B corresponds to Q. And C corresponds to R. So ABC is congruent to triangle PQR. Let's make our statements about sides. Because we've got our conclusion, but we need our evidence. Okay, we have side AB is congruent to side QP. That's given by the three tick marks on both line segments. Given. We have side AC is congruent to side RP. That's also given by those tick marks. And we have side BC is congruent to side RQ, also given. This one was pretty straightforward. That's all there is to it. We're done. Sometimes I like to draw a little square and color it in to signify the fact that we are done. Okay, now we'll prove triangle MST is congruent to triangle RQP. Let's see what we're working with. Okay, I see that I have right triangles, so my first guess, right triangles. My first guess is hypotenuse leg congruence, but that doesn't work because I don't have the hypotenuse. So then I'm going to have to use one of my regular ones. And I see that I have two sides and an angle, and that the angle is between the sides. So that means I know I'll be using side, angle, side congruence as my congruence theorem. Let's write our congruent statement. Triangle PQR is congruent to, and now we have to be careful to make sure we have the vertices correspond. Vertex P corresponds to vertex T, so triangle T. Q corresponds to S, TSM. All right, and I'm doing side, angle, side, so let's make sure we name side, angle, side in sequence. I'll do side, I'll do angle, and I'll do side. First side I'll talk about, it could be either one, I'll do MS. Side MS is congruent to side QR, and that's given. Side QR, already done that one. Okay, side ST, and I'm writing this in the side part. ST is congruent to side PQ. That's also given. And angle S is congruent to angle Q, and that's also given. All done. Next proof. Okay, I see here that I have two angles and an included side. So I know right away I'll be using angle, side, angle, congruence. That means I'll need to make a statement about an angle, a side, and an angle in sequence. Let's write our congruent statement. Triangle ABC is congruent to triangle, let's be careful. A corresponds to D, B corresponds to E, C corresponds to F. Okay, I'll talk about angles A and D first. Angle A is congruent to angle D, and this is given information. I like to do all my angles at once and all my sides at once. You don't have to. The next thing you could do would be the side. You could do the side next, but I'm going to do the angle next. Angle C is congruent to angle F. This is also given by the tick marks. Okay, side AC is congruent to side DF, and that's given by tick marks. Great. Let's see what to do when you have to use justifications that are not immediately apparent. Here we have two triangles. Okay. I can see that they have three congruent sides, so I know I'm going to be using side, side, side congruence. Let's write our congruent statements. Triangle ABC is congruent to triangle What does vertex A correspond to? Let's see, vertex A is between the side with one tick mark and the longest side. That means it must correspond to vertex C, which is also between those sides. B is the obtuse angle, corresponds to angle D, and then the last one is A. All right, we're using side, side, side. Two of the sides are easy because we have tick marks, so they're given. BC is congruent to AD. That's given because they both have double tick marks. AB is congruent to CD. That's also given because they each have only one tick mark. And then this last one. For me, this even feels silly to write, but I know I'm correct. AC is congruent to itself, AC. And that makes sense to write because I still have to make a statement about both triangles. It just happens to be that both triangles have this shared side. The word we use for shared side is reflexive. That means shared side. I just want to make a note right here. Reflexive means shared side. Okay, this one's done. Careful when you have a justification that isn't given. That's when it comes down to studying. You might not memorize all of these naturally. You might have to, make yourself memorize them through work. Okay, next. I see that I have two common angles and an included side. So I know right now I'm going to be using angle, side, angle, congruence. And let's write our congruent statement. Triangle RST is congruent to triangle. I know that vertex R in my upper triangle corresponds to vertex T in my lower triangle because they share the same angle measure. So RST corresponds to T, Q corresponds to S, TQR by angle, side, angle. So in sequence, I'm going to need angle, and then side, and then angle. Let's do our evidence. The angle part is easy. The side, I'll need to use my fancy justification. Angles are easy here, though, because they're given. So I've got angle R is congruent to angle. I can't write angle R. I have to use three letters because it's ambiguous what I'm talking about if I say angle R. Since two vertices use it. Did I make that mistake up above? I did not because I was doing side, side, side. Okay. For this, I need three letters. Angle SRT is congruent to angle RTQ, which is given. As an aside, I'll write, I needed three letters to define angles because they were not well defined with single letters. For example, angle SRT is not the same as angle TRQ. So saying angle R wouldn't have been enough because there are two angles with a middle vertex R. Okay, so I've done the first angle. Let me do the next angle. That's going to be angle STR. And that's congruent to angle QRT, which is also given by those tick marks. And now I need to talk about side RT, which is shared by each triangle. RT is congruent to RT. Do you remember the word? If you said reflexive, you were correct. Let's put another aside. Reflexive here means shared side. You know, it could also mean shared angle, but that's not the case in this problem. Okay, we continue. This is done. Dun, 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 dun. Let's prove that triangle ABC is congruent to triangle CGA. Now let me think. What are we going to use? We've got sides and an angle, but that's not enough. I see that I have parallel sides. I'm going to have to make use of that. Okay, if I were going to extend this side length here into a line, and this side length here into a line, and this side length here as a transversal, I can use alternate interior angles, but I will include a caution here. Angle BCA and angle GAC are alternate interior angles. Yes. Yes. But look, a lot of the time students try to tell me that ACG is alternate interior to GAC, and we don't have information for that. Because in order to be alternate interior, you have to extend from the transversal all the way to the parallel line itself. So there's only one option for this, and it's not here. Okay, we have two angles to work with, a side to work with. And let's see. It seems the side is included with between the angles. So we're going to have angle, side, and then angle as our congruent statement. So by angle, side, angle, congruence. And let's write our triangle congruent statements. Triangle, I'll go BCA. BCA is congruent to triangle, and B corresponds to G, so I have to say G. C corresponds to A, so I have to say A, G, A, C. And I'm doing angle, side, angle, so I'll have to do angle, side, angle. And it looks like I actually have a little bit of a mistake in my template because this extra circle here, it shouldn't point to a side. It should be pointing to an angle because I'm going to use the parallel lines to justify one of my angles. So let me make a quick edit. Okay, I edited this diagram so that this extra circle would point to an angle because I'm doing angle, side, angle, and side is not the one that I needed an extra bubble for. Okay, here we go. The first angle is given, so it's pretty easy. Angle B is congruent to angle G. And I only need one letter for that because it's not ambiguous. There's only one possible angle I could mean if I said B. That's given. The side that is congruent for each triangle is the one which is shared. Side CA is congruent to side CA reflexively. And my last angle, I have to use 3 letters for it. Angle BCA is congruent to angle, okay, now I have to be careful. I want A to be the middle vertex, so GAC. And that is by alternate interior angles, which depends on parallel lines, and that's why you need this extra justification. And I can do that by saying I've got side CB is parallel to side GA, and that luckily is given. Done. This proof is done. And this proof has some major takeaways. Did we do this one previously? Have we had parallel sides? No, this is the first time. So importantly, everybody, note, if you use alternate interior angles, you need to add another evidence bubble where you say what parallel lines you're using to make the claim. Say what? Period. Moving on. Parallel lines again. Are we going to use them? Let's investigate. As a hint, there aren't any extra bubbles added onto this proof. Okay, but let's still check this out. I have angle O is congruent to angle O. I don't have any side information. You know, I don't have any side information. No side information. Information, A-T-I-O-N. All of my theorems require some side information. So I can't prove this. So I can't prove congruence here because none of my theorems are satisfied. I don't have any side information. Can't talk about it. Now, some of you might make a mistake and think that the parallel lines gives you side information, but it doesn't. The parallel lines gives you angle information. So again, I don't have what I need here. Let's check the next one. Ooh, fancy. Okay. Let me write these letters bigger. I've got B, C, D, and A. And I've got parallel lines to deal with, but 2 sets of them. That's a big deal. Okay, let's see about angles. When I look at parallel lines CD and AB, what alternate interior angles can I find? Aha. This angle touches both the transversal and the parallel line, and it is interior. And this angle is on the opposite side of the transversal and touches both the transversal and the parallel line. All right, I'm going to use a different color. Okay, when I look at BC and AD, what alternate interior angles can I find? When I look at this angle, I see that it is interior to the parallel lines, the purple ones, and this angle here is on the other side of the transversal and is also interior to the parallel lines. So it looks like I have definitely enough information. I have angles and sides. All right, let's get started then. I'm going to do it's angle, side, angle. So I'm going to prove congruence by angle, side, angle, congruence. Okay. And our congruent statement, triangle BCD is congruent to triangle. I started with B and then I went to C. So I'll start with D and go to A. D, A, B by angle, side, angle, which means I have to do angle, side, angle in sequence. Let's start with angle, and I need 3 letters because there's more than one angle with vertex B. So, okay, try and vertex D. Okay, so I'll start with angle CBD. Angle CBD is congruent to angle ADB by alternate interior angles. And anytime I'm using alternate interior angles, I need to add another piece of evidence. I need to state the parallel lines which are allowing me to say so. This purple angle is given by my purple parallel lines. So that will be line BC is parallel to line AD, which is given. And I said line, but I should have said side. That's some precision that I struggle with. Okay, BD. This is the side. BD is congruent to BD. And you have to say it, even though it seems trivial, because you're proving that both triangles have that congruent side. All right, and this is reflexively, so reflexive. And the last angles that we're going to talk about, angle ABD is congruent to angle CDB by alternate interior angles. And since I'm using alternate interior angles, I need to justify that. And I'll say, let's see, alternate interior angles. This was the purple, this was the blue angle, so I'm doing side AB is parallel to side CD, and that is given. Was that our last problem? No. Okay, we've got some more. We continue. This one's done. Dun, 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 dun. Here we go. So we have an hypotenuse and a leg, and it's a right triangle. Okay, let's see. So I'll be using hypotenuse leg. So by hypotenuse leg congruence, triangle ABD is congruent to triangle CBD. I'll need to, in sequence, write about my hypotenuse and my leg. And then in order to talk about a hypotenuse, you need right triangles. But that is implied by the word hypotenuse. So I'm actually going to erase that as a requirement. All right, back at it. The hypotenuse here, AD, is congruent to BC, which is given. And then I also want to say, and these are hypotenuse, are hypotenuse. And if you wanted, you could include that extra bubble so that this one wasn't so full. And in that extra bubble, you would have said that the triangles are right triangles, which is also given by the angle being there, the right triangle angle. Okay, leg. The leg which is congruent to both triangles is the one from their shared side, BD. BD is congruent to itself. And the property we use to justify that is the reflexive property. So reflexive. Is that the last one? That's the last one. Students, we got through all of the examples. Yay! Okay, I hope you found this helpful, and I'll see you next time.